my beautiful students. We're now going to be doing a similar triangle proof, which I know proofs are your favorite thing in the world, so I know you're already excited to do example 17, which I am too, so let's get going. Okay, so we are given that AX over XC will equal BX over XD. Now, what that tells me are these two sides correspond and these two sides correspond. And it also tells me that sides are proportional. Now, you're probably looking at the proof and you're like, I thought we were trying to prove that triangles were similar, Miss Long, not that your lines are parallel. Well, what we're going to do, we are going to be proving that these two triangles are similar. Once we prove that they're similar, then using parts of our similar triangles, we'll be able to show that these two lines are parallel. Okay? Which, if you guys remember, if you think back to when we did those parallel line properties, okay, whenever we are proving that lines are parallel, that means that a converse theorem must creep into the mix. Okay, so I already know from my last statement that the reason is going to have to do something with a converse theorem, because converse theorems prove that the lines are parallel. So it's going to be the converse of one of our angle pair postulates or theorems. Okay, so that's kind of our game plan. We're going to show that triangles are similar first using SSS similarity, SAS similarity, or AX similarity. Once we do that, we can show that other parts are either proportionate or congruent, which will help us to show that lines are parallel. But I don't want to give it away yet because I know that you guys are super excited to learn how to do this. So it's like a big surprise and I don't want to give it away. Okay, well, let's get going. So the first step, I always write the given first. So my given is that AX over XC equals BX over XD. So the length, remember, if we don't have a segment symbol above, that means that it's referring to the lengths of your segment. So the length of AX over XC equals the length of BX over the length of XD. Okay, so this is our given. And the importance of this statement is it's telling me that two sides are proportional. Remember, you guys, in similar triangles, it's shown proportional. Okay, I just wanted to make sure I spelled that right because I'm not good at spelling, so there we go. Okay, but anyways, remember when you're trying to show that two triangles are similar, sides must be proportionate. Your angles are congruent, but your sides are proportionate. Okay, so I've shown that two corresponding sides are proportionate. So this is kind of telling me that I'm either headed the SSS similarity route or the SAS similarity route, because both of those require at least two proportionate sides. Okay, so let's see what I can do next, which I can't really grab anything else from my given. Nothing in my given is going to help me write another line of my proof. So I'm going to have to look at my picture and see if I can use one of those nifty tricks up my sleeves to mark any additional angles or sides as proportionate or congruent in my picture. Do you guys spot anything in your picture that might be helpful to writing another statement in our proof? Well, do you guys spot the X? Do you see the X right here? Which types of angles form the X shape? They are vertical angles. And how do vertical angles relate to each other? They are congruent. So I'm going to use that to do two more statements in my proof. Okay, so the next thing I'm going to say, first of all, I must declare that these two are vertical angles. That's the first step. So I'm going to say angle AXB and angle DXC are vertical angles. And how will I know that? Well, that's what it means to be vertical angles. Vertical angles form when two lines intersect and they are across from each other. Or, the shortcut way, they make an X. Okay, so since that's what it means to be a vertical angle, what do you think my reason would be? Holy hot dog, you guys are brilliant. It would be the definition of vertical angles. So, definition of vertical angles. Okay, and now that I have declared that they are vertical angles, I know that they are congruent because that is a property of vertical angle. So if I'm applying the vertical angle definition, what am I using as my reason? It would be the vertical angle theorem. So my next reason, I could say AXB, so angle AXB is congruent to angle DXC. And how I know that is the vertical angle theorem, because I'm applying vertical angles. So vertical angle theorem. Okay, so if you guys see here, I've shown, which I don't have any values in here, but I've shown that two sides in an angle, the sides are proportionate, and I've also shown that the angles are congruent. Okay, which it's kind of hard. I can't mark them as congruent, but like this side corresponds to this side and is proportionate, and like this side and this side, these two sides correspond and are proportionate. Guys, so if you see here, I have like a side, an angle, and a side. And then a side, an angle, and a side. So have I shown that triangles are similar? I sure have. And how are the two triangles similar? They are similar by the SAS similarity. So now I can say a triangle, I'm going to name it triangle AXB. So triangle AXB is now similar to triangle. So if I do AXB, if I trace it, I go from my orange dot to my red angle to my blue dot. So orange, red, blue is kind of what I'm looking. So if I go from orange, red to blue, I'm going from C to X to D. So it'd be triangle CXD. And how I know this is because SAS similarity. Okay, so now that I've shown that my two triangles are similar, okay, what it means for objects to be similar is that all three sides are proportionate and all three angles are congruent. So now that I know that these two triangles are similar, I know that like these two angles are congruent. I know that these two angles are congruent. And I know that AB and DC are proportionate. Okay, that's what it means to be similar. Okay, so we don't really have like a theorem or postulate for this. It's kind of like CP/CTC. Like when we did CP/CTC, after we showed that triangles were congruent, all corresponding sides and angles also had to be congruent. So all the ones we didn't show in our original proof are now going to be congruent. So it's kind of like that. So basically what I'm trying to do is I'm going to use this information to help me show that lines are parallel. Now, you're probably like, Miss Long, you're losing me. Okay, well, I'm sorry. I'm going to bring you back, I promise. Okay, so in order to show that lines are parallel, we have to use a converse theorem. So if I can show that, like, corresponding angles are congruent, or if I can show alternate interior angles are congruent, or alternate exterior angles are congruent, or same side interior angles are supplementary. If I can show any of those properties, that has to mean lines are parallel by one of your converse theorems. Okay, so if we're looking in our picture, if I want to show, which we don't know that this is true, but if I want to show AB is parallel to DC, if I'm trying to show those two are parallel, do you guys spot any nifty letters that are appearing in your picture? Do you see it? Do you see the Z? I have one Z here, and I have another Z here. Okay, I have like a Z, and then I have like an S or like a backward Z. Guys, and if you notice, I have shown that the Z angles are congruent. I know that these two angles are congruent and these two angles are congruent because I have shown that the two triangles are similar. And if two triangles are similar, all their corresponding angles have to be congruent. So which type of angles make the Z shape? They are alternate interior angles. So I have shown alternate interior angles are congruent, which means these two lines have to be parallel. Okay, so we kind of know where we're headed now. Okay, so what I can say, first of all, I can say that I know that angle B and angle D, so I'm going to say, let's see here. I know that angle B and D, as well as angle A and C, and I know that these are alternate interior angles, first of all. So are alternate, I did not leave enough space, interior angles. Guys, so I know that angle B and D as well as angle A and C are alternate interior angles. And how do I know that? Well, they make the Z shape. That's what it means to be alternate interior angles. So I know this by my definition of alternate interior angles. So definition of alternate interior angles. Okay, and if you see here, I already know that alternate interior angles are congruent because if triangles are similar, then their corresponding angles have to be congruent. Okay, so what I'm going to say, this is going to be something new, okay, which we won't have to use this very often, but I can say angle B is congruent to angle D, and I can also say that angle A is congruent to angle C. And how I know this, it's not because of alternate interior angles, because I don't know that these lines are parallel yet. I'm trying to prove they're parallel. The reason why I know is because corresponding angles of similar triangles are congruent. Okay, so that's what I'm going to write right here. I know that corresponding angles, so corresponding angles of similar triangles are congruent. So it kind of has like that CPCTC flow. Like you could technically abbreviate this to like CASTC or something like that. It kind of looks like cats a little bit, kind of. Anyways, if you want to like abbreviate it like that, you can. We don't use this one as often as CPCTC. But it is very true. Also, you guys, you could say corresponding sides of similar triangles are proportionate. So sides are proportionate, but angles are congruent in similar triangles. So corresponding angles of similar triangles are congruent. Okay, which if you want to abbreviate it, if you can remember what that means, you can. So guess what, you guys? I have shown that alternate interior angles are congruent. So since I have shown that alternate interior angles are congruent, that has to mean that AB and DC are parallel. And how I know that is by the converse of the alternate interior angle theorem. So my final statement and reason, I can now say that AB is parallel to DC. Oops, sorry, DC, that's a D. Okay, remember, if you ever have parallel lines, if you're ever trying to prove lines are parallel in your final statement, so if that's what you're trying to prove, you should always have a converse theorem. Okay, that is telling you proving lines are parallel means a converse theorem must appear here. So this would be converse of the alternate interior angle theorem. So interior angle theorem. Oh man, wasn't that proof beautiful? Whoa. Okay, now we don't do proofs with similar triangles as often. I just kind of wanted you guys to see what one looked like. Okay, so hopefully you got some good practice with that. Again, you won't have to do these very often, but that's kind of the idea behind a similar triangle proof. And guess what? Since we love proofs so much, don't forget, we must express our happiness with a smiley face. And I'm going to do a double smiley face and a cat, because that was like the most epic similar triangle proof I've ever done. Nice work, you guys. That was awesome.